In this video, we're going to look at a recursive algorithm, a problem that's naturally solved through recursion. And we're going to think about some definitions of recursive solutions, and then we'll do the implementation for that recursive solution so you can see how a recursive algorithm naturally becomes a recursive method when we write it in Java. So a lot of the kind of more basic algorithms that can be expressed recursively are things that you might have learned about in a math class in maybe middle school or high school. If you don't remember these things, it's totally fine. They're just kind of some things that come to mind in terms of functions that are defined in terms of themselves. That comes up frequently during like high school math classes. So this might be a place where you've seen it in the past. So supposing we wanted to calculate the factorial of an integer number. You might remember the factorial function from middle school or high school. By definition, the factorial function works like this. If we take 0 factorial, the answer is 1, and that's just by definition. Brilliant mathematicians have proved that that's the right value for the factorial of 0, and in computer science, we just accept that. The factorial of 1 is equal to 1. The factorial of 2 is 2 times 1. The factorial of 3 is 3 times 2 times 1. The factorial of 4 is 4 times 3 times 2 times 1. So in general, you can see that when we're taking the factorial of a new value, like if we were going to do 5 factorial, that's equal to 5 times, and then all of the information about 4 factorial. So we could copy and paste all of those values, or we could just write that as 4 factorial. So 5 factorial is 5 times 4 factorial. Similarly, you could write 4 factorial as 4 times 3 factorial. 3 factorial is 3 times 2 factorial, and so on. So if we want to define the factorial function in terms of itself, we could say if a number is less than or equal to 1, so that's the case where it's 0 or 1, then the result's always 1, because the answer is 1 in both cases. If the number that we're trying to find the factorial of is greater than 1, then the result is the current number that we're trying to find the factorial of times the factorial of the next smallest number. So like in our 5 example, 5 factorial, it was 5 times 4 factorial. So in this case, we're defining the result of the factorial function in terms of a smaller version of the factorial function, and that is what it means to have a recursive algorithm naturally. Now, just some definitions related to recursion. That first statement that we have up here is considered to be the base case. It means that the answer's known without doing any work. Type that in here. Answer is known without doing any computation. So if we're trying to find the factorial of 0 or 1, we don't have to like do a lot of calculation for that. We know the answer is 1 in both cases. The second statement here is called the recursive case. It's the case where the solution is defined in terms of the smaller version of the original problem. And so the factorial of a number is equal to that same number times the factorial of the number that's 1 smaller. So it's a function that's defined in terms of itself. And so we've kind of set up how the recursive function would work just in these 2 statements, the base case and the recursive case. That's always true for recursive solutions. If you can write down the base case and the recursive case, then you are good to go. You're ready to start coding that in Java. Now in your notes, I think you have a partial solution already, and we're just adding on to that. So I've already written the main program for you. Set up the scanner, enter a positive integer, that's our number value that we want to find the factorial of. And they have to enter a positive number. So first we just check to see if it's not positive. If it's not positive, then the factorial function isn't defined for that number. So we're just going to print out a message to that effect. If they did enter a positive number, then we can find the factorial of it, and we're going to print out the factorial of number is, and then we're going to make one call to the factorial function. And we're going to write this factorial function so that it repeatedly adds on to the solution using a recursive algorithm. So to do that, we need to know the base case and the recursive case. So we're going to have to think, if the number that they enter is less than or equal to 1, then the result is 1. If it's not, then I want to make the recursive call. So in here, I'm going to use the number that they pass as the argument as my test. I want to see if that number is less than or equal to 1. Well, what's true? If the number that we're trying to find the factorial of is less than or equal to 1, then we know the answer. That's the base case. We want to return 1. So that means we're finding 0 factorial or 1 factorial. Because remember, we've already narrowed it down. There's no negative numbers that are going to get entered. And then otherwise, we're going to be in the recursive case. In that case, we know that the solution is the number times the factorial of the previous number. So I'm going to say return, or actually, I'm going to make a separate value here for Java because it'll make the compiler happier. And temp. Or I could just set temp equal to 1 again. Well, I'll just leave it this way. So otherwise, I'm in the recursive case. I want to set temp equal to the result of multiplying my number, which is number, times, and then the result of calling factorial with the number that's 1 smaller. And then at the end, I want to return temp. Super. So again, this was the recursive case. So again, I've took those two different cases that I could have, the base case and the recursive case, and I just coded them as an if-else statement. If I'm in the recursive case, I'm making a recursive call. I'm calling the method again, so that's creating a loop. And then this base case is kind of like the termination point for the loop. It's telling you when to stop looping. Let's go ahead and run this to see if we get the right results. Make sure I did it right. Oh, I got 2 statements in here that are returns. I don't know how I did that. All right, so enter a positive integer. So we want to pick something kind of small so that we can test it in our heads. So let's do 4. So the factorial of 4 is 4 times 3 times 2 times 1. So 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So we're expecting to get an answer of 24. And that's what our code gives us. That's good. Let's run it again with the base case. Let's run it with a 1. So it tells us the factorial of 1 is 1. Now, just looking at the output from the program, it's not obvious that you're using a recursive solution. There's nothing in the output for this particular example that shows us that recursion is happening. If we want to see the recursion, we could add a print statement in here to our factorial function that says something like, in the recursive call, number is currently number. So we'll be able to see the information about the argument that's being passed in. Let's run it again. Enter a positive integer. Let's do 4. So it's telling us that we were in the recursive call and number was 4. And then we know we're going to have to recursively call it with 3 factorial. So then it calls it again using the 3 value as the number. And then to calculate 3 factorial, we're going to need to make the recursive call for 2 factorial. And it shows us that the number is currently 2. That's the call for when number's 2. You're calculating 2 factorial, which will involve calculating 1 factorial. When we get down to the case where a number is equal to 1, it just will immediately return the value of temp, which is 1. And then it'll start calculating back up to get the final factorial value. If we wanted to see that value being calculated, we could add it in here where we calculate the value of temp. And that will allow us to see the value of temp as it's being created. Let's do that. So for a value like 4, again, it makes those recursive calls all the way until it gets to the base case. And I didn't print out anything when we had the 1 value. So the first value that's going to get printed is when we're returning from the recursive call of 1. We're printing the 2 times 1 value, so it's printing the 2. Then that times 6 is, or that times 3 is 6, and then 6 times 4 is 24. So it's building that recursive value. It's accumulating it by adding on right here when we calculate temp, calculating the current number times the result of the previous factorial value. I'm going to do a separate video where I show the different method calls to help you kind of connect the dots that way as well, to get a better feeling for what's happening behind the scenes when you make these recursive calls.